To the budding video producer or hobbyist, a 1,000 billion byte hard disk drive might seem like a lot of storage. Anyone producing serious quantities of video, however, terabyte sounds like just another snack chip. At some point, an array of multiple disks starts to make sense in terms of space, speed, and security. RAIDs are, almost by definition, inexpensive, but they're not as cheap as the advice we have coming up next on TechKNow. While individual drives have been getting larger and larger over the years, they really aren't getting that much faster. In fact, hard disk drives are currently the big data bottleneck in most editing computers. The interface between the drive and the computer used to be a serious problem for video capture, and SCSI connections were the de facto standard. But today, the standard SATA interface far outstrips what any single hard disk drive can output. So the interface isn't the problem, and in fact, it would be great if we could figure out how to saturate that interface with data. If one drive can't do it, how about two? The acronym RAID stands for Redundant Array of Independent Disks, or Redundant Array of Inexpensive Disks. In any case, it's an array of multiple disk drives connected together to act as one. The most obvious result of this is that you can make two smaller disk drives appear as one larger logical hard disk drive. This is really only a minor convenience, and there are better reasons to RAID, namely increased speed and better security. RAIDs come in a number of different flavors or levels. RAID level 0, or simply RAID 0, works by striping data across two or more disks at once, which has the effect of widening the data pipeline, resulting in much faster performance. Unfortunately, while you've increased disk performance, if one drive in the RAID fails, the entire RAID is toast. So you've basically doubled your chances of losing everything. Of course, a little extra security would be nice. And in a RAID 1 array, data is duplicated or mirrored to both drives. If one drive fails, you always have a redundant backup or mirror ready to go. Read performance is, incidentally, slightly improved with RAID 1, but write performance is not. We're going to skip RAID 2 and only peek at RAID levels 3 and 4, which are very similar to each other and really aren't used very much anyhow. Like RAID 0, data in a RAID 3 or 4 array are striped across multiple disks to improve performance, but an additional drive is also added to improve data integrity. In its simplest configuration, two drives are striped together into a RAID 0 type array, with a third dedicated parity drive added to the mix. Parity drive does not actually store a backup copy of the data on the other two drives, but instead retains error checking information that can be used to recreate data on any single drive in the array in the event of a failure. RAID levels 3 and 4, not very common, but a level 5 RAID is something truly useful for video and multimedia professionals. A RAID 5 array stripes disks together for speed and also uses an additional drive for error checking parity data, but the extra drive is not a dedicated parity drive. Instead, parity information is shared and striped across all of the drives in the array, which can recover from the loss of any single drive with all of the data intact. Fast and secure, RAID 5 arrays are ideal for videographers, and indeed, this is the RAID level we use on our screaming Blackmagic box here in the studio, which captures very high bandwidth HD video from our Panasonic Vericam. There are other RAID levels and some very exotic solutions which we won't get into here, but let's wrap things up with a little overview of how you can get a RAID 5 array into your editing life. The easiest and most convenient way is to buy a pre-built external RAID that connects to your computer via a FireWire, USB 2, or even an external SATA connection. One thing to look for in a turnkey solution like this is a hardware XOR chip, which is used for parity calculations. These calculations can be handled by software using your CPU, but a dedicated hardware chip is the best way to go. It's also possible to build your own RAID 5 array, provided you aren't squeamish about opening your computer case and are willing to do a little bit of homework. Essentially, you need a minimum of 3 matching hard disk drives, and a hardware controller. Each additional drive you add scales very nicely, and 4, 5, or larger arrays are even more efficient and economical. The hardware controller is where you'll need to do a little bit of research. You can create a software-only RAID 5 array, but the computational overhead is significant, and a hardware solution is highly recommended. Many performance motherboards have a hardware RAID controller on board, so some of you might already have what you need. If your motherboard does not have hardware RAID controller chips, you'll need to get an add-on card. Cards range from bare bones to feature-rich and are priced accordingly. The only minimum feature to look for is the hardware XOR processor and support for RAID 5, and a promise of space, speed, and security for video and multimedia professionals of all stripes.